In this video, we're going to look at an example of using calculus to solve a free fall problem. And so, in this example, a ball is dropped from the top of a 179-foot building. Question A, how long will it take the ball to hit the ground? And question B, what is the ball's velocity at impact? Okay, so in this particular example, we have this situation where there's a building, and the building is 179 feet tall. And let's say you're on top of the building, and here's the ball, and you drop it down. So that's 179 feet. Okay, so the first thing we need to do is come up with our position function. So if you remember, S of t equals, okay, so because this is in feet, we're going to have to use the English version of this. So that's a negative 16 t squared minus v sub naught of t plus s sub naught. So the two things we need to know is what was the initial velocity and what was the initial position. Now because we just dropped it, we're assuming we didn't throw it down, the initial velocity is just going to be 0. Okay. Now as far as the initial position, we're just going to assume that this is 0 down here. That means this is 179 feet. So our position function, S of t, is going to be a negative 16 t squared plus 179. Okay, so let's see here. At A. How long will it take the ball to hit the ground? So we drop the ball, when will it hit? And for this model, our position would be 0 when it hits the ground. So the ball will hit the ground at S of t equals 0, when the position is 0. So that means we need to solve this problem of S of t equals a negative 16t squared plus 179 equals 0. Alright, so with this particular problem, we can solve this by extracting the square root. So we'll put the negative 179 on the other side, so we have a 16t squared equals a negative 179. We'll divide each side by negative 16. So we get a negative 179 over a negative 16. So let's get that. What is a negative 179 over 16? We need to get out our calculator. Okay, so over here, 179 divided by 16. So that gives us an 11.1875. Now that's t squared, so we need to take the square root of it. So t is going to approximately equal, see here, I'm going to take the square root of my answer. It's approximately plus or minus 3.34477. seconds. Now, of course, we got to figure out which one it is, and considering our domain starts at 0, the negative doesn't count. So our answer is t is approximately 3.34 seconds. We'll say 345. 3 decimal places works. Good. So now we want to do is part B. We want to know what is the velocity at impact. Now one thing to remember is that velocity equals the derivative of position. So if s of t equals a negative 16t squared plus 179, then our velocity, which is the derivative of position, is going to be, let's see here, a negative 16 times 2 is a negative 32t, and then the derivative of 179 is 0. So here's our velocity function. Now we know it hits the ground at this, notice I kept this number in here, at this 3.34477 seconds. So we're going to put that in. So v of 3.345 is going to equal a negative 32 times 3.3447, equals 204. And so our velocity is approximately going to equal, so we multiply, so we get our calculator back out. We're going to multiply this by a negative 32. And we end up with negative 107.032705.3. So we'll answer this by saying that V of 3.345 is approximately a negative 107.03 feet per second. And there's our answer. So here's a good initial example of how to use the concept of a free falling body, basically, in this case a ball, and figuring out some information from that. And we were able to figure out when it hit the ground and at what velocity it is hitting the ground.